Unit 7, Lesson 4. Unit 7, Lesson 4. So arithmetic series. So the key thing is I want you to recognize is the first two we were talking about sequence, right? This is series. The difference between sequence and series is sequence is the pattern. Series is we're going to add the pattern. We're going to make a summation out of it. Okay? So series means addition of the pattern. See how they put plus signs? So you have the pattern, the sequence, versus the addition, okay? So the symbol S of n is used to represent the sum of the n terms in the series. So above there, S of 5, because there's 5 terms, what would that be? Well, you just add them. 8, 15, 24, 35. So that'd be 35 for that first quick example there, if I added the 5 terms there. Summation, yeah. For every series, you add the pattern, yes. Yeah, it's called a summation. Okay, so we're going to do a quick investigation here. It's actually kind of interesting, I think, for this one. And this is a true story. I actually did weirdly enough, you probably don't care too much, but I actually did a report on this guy in college, Carl Gauss, so just a famous mathematician, just part of my history of math class, which was riveting. So, what's that? Yeah, just part of the requirements. But there's something that was interesting about how stuff. What's up? Well, I mean, it was more like the history piece of it, of like Euclid and different mathematicians that kind of created some of the pattern. Well, not created, but came up with the relationships of math and how they relate to real world things and stuff. So, I mean, it is interesting that aspect, seeing the ground level. Okay, but anyway, Gauss was, so it says to illustrate the term and formula for sum. A great story about him was when he was 10 years old, so this is also crazy, think about he's 10, okay, he's placed in Master Butner's arithmetic class. Master Butner often gave his class long arithmetic problems to keep them quiet for a time. Okay, on a particular day, that teacher would ask him to ask the class to add all the whole numbers from 1 to 100. So he said, I want to know add up all the whole numbers 1 to 100. So that means 1 plus 2, 3 plus 4, and they just have to keep doing that just to make them practice their arithmetic. Okay? So while all the students began to work madly on the assignment, Carl laid his slate on the desk and informed the Master Butner he was finished. Master Butner asked Carl what his answer was. Master Butner astonishingly gave the correct answer of 50-50. It says, here we apply a similar method to how he did this, and this is how he made it a short version. If you have a sum of 100, right, adding everything up from 100. If you have another sum of 100, you're adding everything up from 100 backwards, let's just say. Okay? We're just writing it 2 different ways. Well, if I added these 2 lines, it'd be 101 for all of them, correct? See how that kind of happens? 101, 101, 101. So what he did is 2 of these things he wants me to do, 2 sums of 100, are going to be 101 100 times. Right? There's 100 pairs here, right? Correct. And so, what'd you say? 101 times 100, but then we're going to have to divide that by 2 because this is 2 of them. We only want 1. Does that make sense? Okay, so this is kind of how he came up with the pattern. So you just kind of see it just keeps going 101 plus 101, and then plus dot, 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 just 101s continuously. Okay, so essentially what you're seeing is it's going to be 2s100 is equal to 101 times 100. So then 2s of 100 equals, when you multiply that, you're going to get 10,100. And then you divide by 2 for the answer, which is 50-50. So that's how I figured out the pattern without doing every addition. At 10, yep, that's the crazy part. That's why he's a famous mathematician. Yeah. Okay. So where we're going with this is how these work. Formulas of sum of arithmetic series are going to be in the form of a plus d, a plus 2d, etc. That's just the pattern. And what it is just double the difference, right? You have your first term plus the difference, first term plus 2 differences. So this is the first, second, third term. They're just writing the pattern that we did yesterday. Well, when we do that in terms of a summation, you're now just, instead of this system just being a pattern, you're going to sum them. Well, when it comes down to it, okay, instead of just going through this proof with you, you're essentially going to get this formula, which you get, so you don't need to memorize. You get this formula for all tests and final and all that stuff. It's going to be sum is n. What's n stand for? Term number. 2a, what's a stand for? Start. N again, term. D, common difference, over 2. So you just plug all those values into that form, and it'll get you essentially the answer. If you kind of think about it, this is what he came up with, right? This is what he came up with because he's dividing. See the divide by 2? We divided by 2, right? So what he's doing is he's doing the term number, however many terms, times 2a's plus n minus 1d, all divided by 2. It's essentially writing his method in a formula. Okay? Any questions? Now, there's two different ones based on what you know. So, for example, this one's best used. Let's see if you guys can answer this. Notice the difference here. This one has t sub n. So t sub n means that we know like a location, right? So you can use this one when you have n, a. Notice that we don't have a common difference. So this could be used if you don't know what d is. Okay, if d is missing, this one could be used. If you have everything, that one could be used. Okay. All right. So let's try a couple here. So we're just using the formula here. So turn the sum of the first 14 terms of the arithmetic sequence 9, 15, 21. Okay, so let's write them down. You want to write them down first. So a is 9. Common differences 6, and n is 14. Have everything we need. So now we plug it in. So I'll write the formula one more time, and then I'll plug it into it. S sub n is n times 2a plus n minus 1d all over 2. So that's going to be for us. S sub 14 is 14 times 2 times 9 plus 14 minus 1 times 6 all over 2. I would simplify this first before you put in your calculator. There's a lot of brackets going on, and it's not hard arithmetic or stuff when you're doing it. It's like, for example, this is an 18. This is 13 times 6. 13 times 6 is 78. So you have 18 plus 78. Yep, 78. And then it's what's 14 over 2? 7. So it's going to be 7 times 90, what'd you say, 8 or 6? 96. 7 times 96, essentially, what you're going to do. And that's going to be 672 is your answer. Okay. So notice this one here. It says determine the sum of 22 terms of an arithmetic sequence t1 negative 18, t22 45. So what would this be in terms of, notice what are we missing? So we might use that second form. Okay, that second formula down there at the bottom. Okay, so we're going to use, let's see here. So what do we know? We know that A is negative 18. We know that we're going for term 22, which is 45. And we know where n is 22. So the form is S of 22 is 22 times negative 18 plus 45 all over 2. 45 is in t22. That's what the t sub n is. So negative 18 plus 45, that's 27 times 22, or 11. Yep. Okay. That would be what? That's the sum of all the numbers of 22. If you add all the numbers of that pattern from 22, it's going to be 297. Now notice one thing about this is you're thinking, well, wouldn't that be bigger? Well, that's a good guess, but it's not bigger because it starts where? It starts in the negatives. So you actually have some things you're adding that are making it smaller, right? You're having some terms, but as it's growing, that's making it smaller. Now remember, how can we find the common difference? Do you guys know how we can find the common difference real quick? Do that like slope form, right? We can go 45 minus negative 18, 22 minus 1. And divide, that'll tell you the common difference, right? Because this is a constant. So that's how you can figure out what the d was if you need it. We didn't need that. That's what this formula helps us with. Okay, we don't have to have it. I'm just saying if you needed to find the common difference, you would simply go 45 minus a negative 18, so that's plus, over 22 minus 1, which is 21. So what is it? 3. Okay, so it ends up being 3 if you wanted to know the common difference. Okay, cool. Right, if you want to find the common difference, you can just use that first formula, correct. Okay, a couple more here. Find the sum of the terms in sequence 17, 12, 7, negative 38. So what's the work we have to do here? Because either formula, we need to know what? What's that? Yes, n. Okay, either formula, we have to know n. We have to know the term number. So this means, go back to last lesson, we have to figure out what term negative 38 is. Last lesson or our warm-up we just did, right? So we have to solve for n first to figure out what negative 38 is. So this is clearly going down by 5. So that means I have my d is negative 5, my a is 17, and we know that t sub n is negative 38. And now we're going to solve for n real quick. So we write it as negative 38 equals 17 plus n minus 1 times negative 5. Okay, I think I'm going to stay with how Nolan was doing. I don't like to distribute either. I'll divide first, but with minus 17, so that's a negative 55. Divide by negative 5, 11. So n is 12. That's the 12th term. That's the 12th term. What's that? 22. 55, yeah. So now what we're going to do is we have everything we need to use either formula. Okay, it doesn't matter which one. I'll just use the first one. So I'm going to say s of 12, because that's a 12th term, right? S of 12 is 12 times 2 times 17 plus n minus 1, which is 11, so 12 minus, so it's 11 times negative 5, all over 2. Okay. So another thing you can kind of see is just let's use some common reasoning here. If this right here is 17, and I'm going to negative 38, is there more negatives or more positives? There's more negatives, right? Because my right end's higher than my left end in terms of negative positive numbers. So my point is, when you add all these, you should expect to have a negative answer. My negatives will outweigh my positives. Does that make sense? Okay, so what we'll do is, let's see here. 34, 12 over 2 is 6, so it's going to be 6 times 34, negative 55. 34, negative 55 is negative 21. So you should have negative 126. Negative 126 is your solution there. Okay, for S of 12. Okay, right there is fine. Just a bit. Okay. Yep. The question asked me to find the sum of the terms. Yeah, and so we needed to know what term number that was. So that's the first work, to find the term number so we can find the sum. Yeah, so it was a two-part. Okay, any other questions? Yes? See it? Okay, so example 4. Peter, start work at salary of $16,000 per annum. That just means per year. He sees annual increase of $850. He works for the firm for 12 years. Calculate his salary in the 12th year. So let me ask this. Do we want to know his salary, or do you want to know how much he's made in 12 years? Right, so is that a term, or is that a sum? It's a term. We want to know how much he's making that year specifically, so that's a term number. Okay, so what you know is, okay, he starts with 16,000, so that's his A. His common difference, he says he gets an $850 raise. That's his D. Okay, and the term number is 12 for us on this one. So we're going to calculate that. So term 12 equals 16,000 plus n minus 1, so 11 times 850. So his 12th term, or his 12th year, he will be making $25,350. Hopefully he's not living in Calgary. Yeah, that won't work. Okay. Now you see the next question is what I kind of got you guys thinking about, is now it's how much he's made in 12 years. Now that's a series. That's a sum. So now we use a sum formula. So it would be 12 over 2 times the 2 times 16,000 plus the 11 times 850. Okay, 12 over 2 is 6. So 6 times, see, that's 32,000. 32,000 plus, let's see, what is 850 times 11? So that's 8,500, 9,350? 9,350, yeah. Okay, so that's 41,350 times 6. So what is that? 248,100 is what they get there. Okay, 248,100. I think for the sake of time, guys, and I've done this quite a bit, this next investigation, I'm just going to kind of skim through for you. I do think it's kind of common sense, but that's just me. Okay, so this second investigation just goes through showing you that if you subtract, if I go S of 4, like series 4, and I subtract S of 3, it gets you a term number. Okay, so let me just show you a quick example that I'm not using this. Let's just say that my pattern is very simple. It's 2, 4, 6, 8, 10, 12, going by 2s every time, right? So what I'm showing you is if I do S of 4 minus S of 3, that's going to equal term 3. So S of 4, so we can just do this really quickly, right? 1, 2, 3, 4. That's 6, 12, 20 minus 2, 4, 6, that's 12. Or sorry, term 4. 20 minus 12 is 8. You get that term number. Okay, so if you take the series number minus the previous series number, it gets you that term number for the one you started with. Right, the summation. Right. So that would help you if they said, hey, the series is this and this, what's the term number? You could go, oh, you just subtract the two closest. Okay, so that's all this investigation is showing you, but I do think the examples will just be easier. But this is the formula. Series of n minus the previous series, okay, gets you the term of that first n. Okay, so that's what I said. I did S4 minus S3. That equaled T4. Okay, what's it mean by n greater than or equal to 2? Well, you have to do the second series, right? Because you can't do the first series minus the 0 series. There's no 0 series. So you have to start with the second one at the minimum. All right, so let's go ahead and see how this can help us. For a certain arithmetic series, S of n equals 1/2 n times 11 minus n. Determine the first 4 terms of the corresponding arithmetic sequence. So what they want you to do is, this is the pattern. So we got to figure out, okay, what's S of 1? So we're going to plug a 1 in for n. So that's going to be 1/2 1, 1/2 of 11 minus 1, so 1/2 of 10. Do we see that? So it's 5. Okay, I'm going to find the first 4 terms here. S of 2. S of 2, so 2, half of 2 is 1. 11 minus 2 is 9, so it gets to 9. So that 1/2 goes away. Sorry, it's a 1. 1 times 9, so you get 9. All I'm doing is they're giving me an equation for the series. I'm just plugging in values for n and getting what they are. Okay, we're not having to do the whole formula. So 3, if I plug a 3 in, that's 3/2. 11 minus 3 is 8. 8 times 3/2 is 12. Is that right? 24 over 2? Yeah. Okay, S of 4. Okay, S of 4 is 4 times 1/2 is 2. And then 11 minus 4 is 7, so I get 14. All right, so what they're trying to get you to figure out is they want all the 4 of the term numbers of the pattern, though. And so see how we have the series outputs? So what we can do is we're going to do this. We're going to go S of 4 minus S of 3 equals T4. S of 3 minus S of 2 equals T3. S of 2 minus S of 1 equals T2. S of 1 equals term 1, by the way. Why? Because if I had a pattern of one number, the series and the term would be the same number, right? If I had a pattern of one number, the series and the term would be the same number. Like if I said 5, 10, 15, 20, and I said, what is S of 1? Well, it's 5, because it's the first one. So T1, S1's the same. So we can kind of cheat right now. 5, show them this one, that's term 1. Okay, so what is term 2? 9 minus 5. 4. Because it's second series minus first series. Right? So this would be 3 and then 2. So what does this mean? And check this out. Notice what happened here. See how the gap between these kept getting smaller? That means that my pattern was getting smaller. Because if it was growing, it was getting bigger, my gap would have got bigger. Okay, they would have grew farther apart. Does that make sense? So here, use this for a quick example. If I did a quick series of this, it'd be 5. The second series would be 15, 25, 30. See how they're getting wider? Because it's growing. This pattern, is it growing? No, it's decreasing. That's why these were getting closer together. Do you see what I'm saying? Then here, this last one would be 35, 55, 45, 50. So you see how these are growing? Because it's a growing pattern. This is a declining pattern. But that's it. Okay, for series.